Hello and welcome to Math, Minecraft, Computers, episode I10, Introduction to Logisim. This is M. Roy, and today we're going to talk about Logisim, which is a logic simulator program. The link is provided below in the description of the video. You need to download it and get it installed. It is a Java-based program, so you'll also need to install Java for this to work. And what a logic simulator does is it lets you design circuits on the computer and test those circuits using the computer instead of real equipment or building them in Minecraft. But once you have a circuit tested and debugged, of course it's very easy to transfer that design into the real world using various chips to perform that logic, or of course in our case it's even easier to do that in Minecraft. So when you're doing something very complicated or something that's a little harder, it makes a lot of sense to do all your work inside of Logisim first. Now this is Logisim when you first start it up. It starts this way. You have this little button which lets you modify and edit wiring. As you can see, it says edit selection and add wires. And then over to the left you actually have where it says test. Okay, so this is where you actually run the simulation and change the values within the circuit. So we want to start with, make sure we start in this arrow. Then down here we have various categories of things, including wiring. You see, most of these we won't use in designing for Minecraft, but doing actual circuits you would need those. So I double click to open these. So let me double click gates and you'll see our familiar gates here. We have our AND, our OR, and our XOR gate here. We also have the NOT gate or the inverter here. You can also see that we have the NAND as well, and some gates that we have talked about but haven't built, the XNOR and the NOR gate. So let's start by dragging these out. I'm going to grab each one of these. I click on it and then simply come over here. And this is the design area. I can just click and drop it and it shows you that it's selected that gate. Now it's got an input in blue and an output in red. All I have to do to connect those, if you see when I move my cursor over, I get green outline. You just click and drag while holding the mouse down, and this is a wire. And I can drag that wire and it will adjust. So we'll just do this for now. I would do the same thing over here. So here's our input in blue and our output in red. And red indicates there's a problem. Here's the AND gate. There's a couple of different ways these are. If you look over here, here's the inputs. You can see there are 1, 2, 3, 4, 5 by default. But I can come down here to this number of inputs, click there, and change it. Say I want to say 2. This is the output. So once again, I'll just drag these out by clicking and dragging wires from here. We have the same thing with our OR gate. These are the logic symbols that you'll encounter all the time. The AND is this shape. An OR is kind of like an arrowhead. I can do the same thing here. I could change that to 2, but I won't. Instead, I'll just connect up some wires by clicking and dragging. Click and drag. And then the last one that we've studied, of course, is the XOR. It's right here. It looks a lot like the OR gate, but it has a additional line back here. And same thing. I'll just do this, pull this out. So that's how you hook them up. The last one we have talked about, I'm going to put it right here by the AND gate so you can see. This little circle on any circuit right here, this little black circle you see in the one here, indicates that a signal is negated or inverted. That's why this is a NOT gate. That means the difference between an AND gate and an AND gate is your output is going to be inverted. Right here. Now it's actually possible in Logisim, which may or may not help you, that you have these here, which says negate top and bottom. Or if you notice when I click on one of these, it has more than one. It says negate top, bottom, it's showing. So if I turn these on, you'll see you get the little dot there. It's saying that it would negate that input for you. And that is necessary for different types of logic. Certain chips may do this, or it's a way to, if you're just doing circuitry, and you just want to make sure that you're engaged, you have an inverting input, or you just don't want to do your NOT gate somewhere. That is a way to do that. So those are all individually selected. And the way these are hooked up is just like we normally do. This is an input pin right here. So I'm going to grab this input pin and drop it here. Now the other thing that you can do with these is you have facing. You can see that the input pin's input is coming out to the right, which is east. East is to the right, north is to the top, west is to the left, and south is to the bottom, just like you're reading a map with north on the top. Now I can turn these by selecting an item and saying, I want you to face, in this case, south. And now I can drag a wire here directly into this gate. Now I see it immediately turns to a green state, indicating that red, there was an error, but light green or green is good. So that means this wire here is a dark green color, means that it is not activated. So if I go to the finger or the hand here and click this wire, it shows you everything that it's hooked up to. So I could actually come back here to the edit state, and maybe I drag that wire over to here. Now when I click it, it's showing you that that wire is in the off state or the 0 state. It shows you the 0 right there. It is not powered and where it's going. Now if I click this, it'll turn that from a 1, or excuse me, 0 to a 1, and now you can see that it's light green. If I click on it, it'll show the same thing. Now it is activated or 1, it's going into here, it's also going into here. Both of these are indicating that they have an error still because they're not connected up. But you'll see with a NAND gate, if I only have one connected up, that means that I have no inputs, so it turns on. So maybe I add another pin, and I'll show you how that facing works. I'm going to click here. This time I'm going to face it north. And you can see it now comes out to the top. So I can just connect it to here, let's say. And what you can do in Logisim you cannot do in Minecraft is you can cross wires. So if I come over this way, and all in one motion move up and then release, I can connect there, and you see it does not make a connection. It makes a dot where there's a connection, so it is not connected to these two wires. So when I come back to here and I turn this on, you'll see that this one is now activated, but this is not active because I don't have them both on. This is an AND gate. And this one is active because it's saying both of them are not on, so therefore it's active. If I click this, it'll be the opposite. Now the AND gate is active. You see this turns green because they're both on, and the NOT gate turns off because they're both on. Now the last part you can do is you can go to the input output here and select the LED if you want. You drag it over to here and have it face west. Then it is connected to here. Now it will turn on when this gate, this wire right here. So that's indicating that this is an on state. So that's how I can do the same thing here. So this one is on, this one is off. We know they're opposites. As soon as I turn this on and this on, they'll change states. So that's on and that's off. And so that's how it works. Now I'm going to get a new one. We'll start over here. I'm going to go into my gates by double clicking here, and we're going to build our 4-bit bus. So I'm going to get pins. These are our inputs. I'm going to have them face south, and I'm going to put one right here. I'm going to drag a wire straight down. This would be the on state, of course, because it's connected directly. And just like in Minecraft, when we did this in our work in Minecraft, we want to also invert it. So if we get a NOT gate, I'm going to face it south, and I'm going to drop it right here. And then I simply connect it into this wire and drag one from here by holding down and dragging out. Now you'll see exactly what we have. This is showing you that this wire is active and is in a 1 state because this input is off. But this one is in a 0 state. As soon as I click here, now I get the fact that this is 1, this now becomes 1, and this wire becomes 0. So that's exactly what we did in Minecraft. And of course, for a 4-bit bus, we need 4 of those. So I'm just going to drag a box by selecting up here, holding down and dragging to open a box select, and I'm hitting Control-C for copy, and then Control-V. Now when you do this, you want to make sure you don't get any sort of wires coming out of here. It's very easy to do. So anytime that I get a green circle you see there, that means I'm on a connection. So instead you want to just click somewhere else and connect it up like this. Same thing, I'm going to do a V, Control-V to paste, drag this one over here, Control-V to paste, and drag my final one over here. Now if you want to move something, you can just simply select it, and then grab it, and you'll see that it moves everything all at once, whatever your selection is. Now it is possible to do labels too. When you select a component of any type, you'll have a section down here where it says label. You can put whatever label you want there, and it will show up. Now, it's all set for north. I've already done that, but normally it'll be set for west. And you can see it shows up over here on the left. But of course I can choose that and do any of these. For instance, on the top would be north and it would show there. Obviously a bad choice here would be south. You can see the labels below, but it does let you move the labels around, and you can see you can do that for everything. When I don't have anything selected, then I can set the shared label facing, and this is the default. You can also change the font here if you want it larger or smaller or bold or whatever. For instance, I could do bold in this and say OK. And then when I create a new one for here and say C, since it's not a new, I don't get my changes, but when I create a new one, I will get that. It could look like this. All right, I'm going to go ahead and just label these real quick. I'm not going to do bold. I'm going to make this B, make that north, and then this is going to be C, or excuse me, A. And we've got our labels in place. So now we created the same 4-bit bus we did in Minecraft. You can see that we have 4 bits. I can turn them on or off by going to simulation mode, turn these, and you'll see it will invert from the inverted off state to the on state, depending on the wire. So that's exactly what we had before. Now let's do that same circuit that we did. If you remember, the first circuit we did in I10 was to create a circuit that would only come on if all the wires are on. And we did that with it on, because we said if A is on, and B is on, and C is on, and D is on, then we want to actually have an output. So I'm going to get an AND gate, click on it there, and I drag it over to here and drop it in this area. And then I just connect up my inputs. Now in this case, I'm going to go ahead and change this to only 4 inputs coming over to here, like so. And I'm going to connect them to the on wires. So that is the left in all of these cases. So there is C, and here is D. And then of course we can drag this out. To make it easy to see, I'm going to go ahead and go into input output here, double click, grab the lead, it's facing west, we're good. That is an LED light emitting diode, and there we go. Now when I go to the simulation mode, remember if I just click on these, I'm actually selecting them. I have to go to this mode first, and now I can change the values. And so one of the ways that works is I'll click here. You can click now here, and it'll show you exactly where all that wire is connected. So it's a good way to debug a circuit when you have a screen full of gates and wires. Go ahead and click this on. So now we have A and B, still no output because all 4 wires must be on. Turn on C, turn on D, and finally we get our output. Let's do something that we did before also. We're going to say if A is on and D is on, so those 2 must be on. That's an AND situation. So we're going to grab an AND gate and put it here. In this case, it can only have 2 inputs. I don't have to change this, but I'm going to. The other thing you can do also right here, you have gate size. You can make it wide, which is very large. You can make it narrow, which you see is smaller. And then of course the default is above right here. That's medium. So now I have a 2-input AND gate. I'm going to connect that to the bit on here and the bit on D. So A on and D is on. That would do an output this way. And then my other one was if B or C. So if A and D are on and B or C, then I want this on. That means I need an OR gate. I'm going to do the same thing, drag it here. I'm going to set this for the same size for now and set it for 2 inputs. I'm going to line it up here just by clicking and dragging. And then I simply grab one of these, see the green circle, and drag it over. Remember we said if B is on, same thing here, click, and then drag over to C is on. Now I have these 2 gates. Now the last condition, remember, if both of those conditions are on, we want our LED on. And just to be consistent, I'll make this narrow as well with 2 inputs. To connect these up, all I do is pick either here or here and drag. Now you can bend a wire quite a bit, but you'll notice that it does 1 bend at a time. So I can bend up or down, but when I try to bend again, so what that means is very often you might need to, in this case I need to go up and then over. If I try that, you'll see how it connects. So instead I drag to here, release, and then simply start dragging again to there, to here, and then I'm going to come down to here and over. And then I'm going to do, instead of getting a new LED, I'm going to click here, Control C to copy, Control V, and drag down to here. Now this circuit should be on only if A and D are on. You can see that this wire is now active because A and D are on, and either B or C or both. So as soon as I click one of these, this LED should come on, and you can see that's exactly what it does. Doesn't matter, I can have them both on. Now, what's also, you can see it demonstrates that Logisim is going to do all of these conditions. So when B comes on, this light comes on because this is met. When I click C, this one comes on as well. So this allows us to do fairly complicated designs. And doing circuits inside of Minecraft is great, but when you get complicated and you're trying to put it all together and make something complicated, which we'll be doing soon, it gets kind of difficult. So this lets you do some design. For instance, let's take a look at how we might say, I want a condition where A is on and C is on, or B or D. So in other words, every other is on. So if on, off, or off, on is the case, then I want my output. Now this gets a little more complicated. Now if you can think about how we could do this, this very straightforward way is to think of it, well, I have two AND conditions, right? If this is on, let me get an AND gate out here. I'm going to leave them big, and I'm going to set them for, we have a couple of different ways we could do this, right? However you want to. I could say, if this one is on, so I'm going to bring that to be A, and if B is off, that's what we have right here, because that's the negated B, and C is on, and D is off, like this, then I have an output here. Now we don't have that condition. We can test it simply by going here and saying if A is on and C is on, so A, B is off, C is on, D is off, there's our pattern 1, 0, 1, 0, then we have an output here. So that is one condition. Now the second condition that you might grab is, I can select AND gates up here too. It's kind of a shorthand way because these are used most often. I'm going to drag it here. I'm going to leave it set for 5 inputs, that's fine. Now it's going to be the opposite condition. If A is off, B is on, that's this wire, C is off, and D is on, then I've got the opposite condition, and I'll drag this out. So now, turning any bit's not going to do anything here. I can turn all of these on. I can turn these two on. Nothing's going to happen. What I really have to do is turn them on in such an order that it's every other one. So let's turn that off and that off. You can see this gate is active. If I reverse this condition, then you can see this gate is active. How would we complete that? We said if this condition is met, or this condition is met, we want the light on. So that is, of course, an OR gate. And I can put it right here. And I can grab this wire, put it in any input. Same thing here. We'll grab our LED from here. Control V or C and V and connect this up. And so now we've actually built our circuit. So it's pretty easy. Turn it off this way, I get it on, or invert that, and I get the same thing. Now this might be a situation where maybe you don't have a 4-input gate in Minecraft. They can be as big as we want them to be. Okay, so to continue on, I took each one of these wires and dragged them down here to make them a little bit longer. And when you do that, you just grab and connect. Now you got to be careful going left or right, because if you connect them up, for instance, like this, you're going to get red. That means that all of these wires are now invalid, because I haven't this connected directly to another input, and that is a problem. So to fix that, I just delete this. So when you're doing this, just make sure. I'm just going to drag them down to give us a little more room, and we're going to work on another circuit. Here we had if this is on in a pattern of either every other bit, one way or the other, this way, or this way, then the circuit is on. Now we can do a circuit where we say if only one of these is on, only one wire and only one wire at all. Now we could do that very easily by simply grabbing an AND gate over here, setting it for 4 inputs, and setting them exactly the way we want. So we would say if A is on, and B and C and D are off, then I'll have this condition properly. So what that means is, in this condition, I now have a positive here, I would do another gate, except I would connect it to the B. I would have 4 of those gates. If you don't see that directly, I'm going to do that. You can fast forward a little bit why I connected up, and you'll see the difference. Here we go. Alright, so here we are. So now we can test our system and see exactly what happens. When I turn A on, you notice this one comes on. If I turn any other one, it turns off. So any other combination, it actually turns off. So if I do the same thing here, turn B on, you'll see this one's on, turn these off, anything else that goes off. If I leave C on, this third gate comes on down here, and then of course the last one is going to be D. So that's one way to do it. I have 4 gates, each of these are an input. And then, of course, the last I would say, what? If this condition, or this condition, or this condition, or this one, that means I need an OR gate. It's going to be very similar. Drag it here. It has, in this case, we'll do 4 inputs as well. And we just take each one of these and we connect it up. Like so. Last, let's add our LED on the end of this. There it is. So now, as long as only one is on, I'll get the LED coming on. So no matter what combination I pick, I can only have one on. But you might ask yourself, how could I do that another way? If I didn't have input gates, or I want to use a minimum number of gates. Now the reason you want to use a minimum number of gates is propagation. If you remember in Minecraft, we're using redstone, we have to do redstone repeaters, so if we're moving down a wire and we have to enter this gate, and then we have to enter another gate like this, there's a certain amount of time that propagates. So in Minecraft, you want to do as big a gates as you can, and you want your designs to be as few levels, meaning here's 1, 2, 3 levels for this one to work. This one has a single level, it has right here. I have an input going to a gate, so it's 1, 2 levels. This is 1 from the input, 2, 3, and we have 3 levels down here. But these could get very large. Let's say you have a condition now where you want to say, well, I either want a situation where only one is on, but I also want a situation where they are all on. So here is our all on gate right here. And here is our only one on situation. What I can do, the first thing you might want to do, is you could add a circuit, say something like this. I'm going to add a label and say only one on, and up here I'm going to say all on. This helps you keep everything straight in your head. So those 2 conditions are met. So how would I do that? I said if either is on, that's an OR situation. I'm going to drag an OR gate out of here. I'm going to make it 2 inputs for clarity. I'm simply going to go behind this, drag it up here, and in. And I'll do the same thing here. And finally, we'll do an output coming from it. So now we have if they're all on, or if only one. So as soon as I turn this, this will light up, which will turn that on. So now I have a different propagation. I have 1, 2, 3 in this route, but I have 1, 2, 3, 4 in this direction. So this side of the circuit detecting this condition, where only one is on, would be slower in Minecraft simply because of the distance it has to travel. It has to propagate from the input to this gate, to that gate, and finding the output. So if we count them all, it's 1, 2, 3, 4 devices. And this way it's 1, 2, 3, 4, 5 devices. So Minecraft, you want to keep them as short as you can. You don't always have that same ability necessarily in others. Now the last thing we're going to do in this lesson is I'm going to go ahead and say new. It'll open up a second window. You can see I still have that. Untitled. And then here I have Untitled 2. I'm going to rebuild that 4-bit bus for you because we want to save this. So once again, this is your homework. How do you build a 4-bit bus? Pause the video here and then I'll show you again. Okay, here we go. I'm going to start by setting this south. That makes it easy. I'm going to copy that and spread them out across here like this. That's going to be where we want them. If that's just for my own clarity, then I'm going to drag a wire straight down for the positive, and then I'm going to do the same thing here. South. Put an inverter here, drag the wire over from the inverter to there, and then drag this down. I missed my circle, and there we go. In this case, I've made it wider. It might be a little bit easier to see. And then all I have to do is select this, copy it with the Control-C and V, and just set these here. 1, 2, and 3. Connect these up to each one of these. The last thing we need to do is label. A, and we want a label on the north. B, label on the north, and so forth. C, and D. Now, while we have this, you could move these around. If you want them closer, you could grab these and move them over. It lets you do that largely. I actually drew a wire. When you do something like that, Control-Z. So you see, I can move full circuits around if I want. It will also try to rewire. We're going to stop right there. We're going to leave it. And we're going to save this by doing here. Save as. And then I can go wherever I choose and keep my signs. You'll see you have a 4-bit bus. And we would just put a label in here, call this 4 bus, and save it. And now we have this file that we can start anytime we're working in 4 bits. We have our bus already drawn for us. And that's where we will start next time as we design something a little bit more difficult than we've done in the past. Thank you. This has been I10, Introduction to Logisim. Hope you enjoyed. Have a good time learning. Imroy out.